For this project, here is the result of my doing, and no switches on. It will be 0, and 1 will be 1, and 2 will be 2, 3 will be 3, and 4 will be 4, 5 and will be 5, and either to choose neither one of them, it also will be the same result. And for explain my thinking of this project, for the first approaches, I just list all the 32 possible inputs for the x1 to x5, and we got 3 outputs, f2, f1, and f0. We list all the 32 possible ways, and we found only 5 outputs will be shown in this list, and so I used the POS here because the 1 will be really less than the 0, and for the F1 we will choose the 0 to write down the POS expression, because the 1 will be much more than the 0, and for the F0, 0 and 1 are half, so either choose them are okay, but I choose the SOP in my code. And here is the code of my project. 3 output, 5 input, and the 3 expression for the F2, F1, and 0, F0. And also I compiled this project, and here is no errors and 12 warnings. For the second approaches, I choose the 3 to 2 and 3 inputs. Here for the first 2, I use the adder module to have 2 output, and for the second, I use the 3 to 2 module that will be 3 inputs and 2 output here, and both of them will have 2 outputs and totally have 4 output, but I will use the 4 outputs as the input for the second module, and we will have 3 output here. And for the other module, we have the example in the book, and for the second 3 to 2 module, we will use the K-map to get a result here. And for this large 4 to 3, we will also use the K-map here for F2, F1, and F0. So by the K-map, 1, this line, and this line, all of 3 will be don't care, and we circle the 1, and circle the 1 to write down 3 expressions for F2, F1, and F0 here. So here will be the second code for the project, and here will be the first module, and for the full add for the input here, this will be the first module for the adder, and here will be the second module for the 3 to 2 module, and we used to have the F2, F1, and F0 here. And I also compiled this project, and totally have 12 warnings and no errors. For the third approaches, I just used the 5 possible of the 3 outputs, and associate them with the 7 digits display here, and 0, 1, 2, 3, 4, and and for the totally inputs, we will calculate the f is equal to x1 plus x2 plus x3 plus x4 and plus x5. The computer only can calculate the binary calculation, so it's only be 1 and 0 is possible. So the f will directly to be the the same as the F2, F1, and F0, like 0, 0, 0, 0, 1, and so on. It's 5 possible. And but in this project, because we calculate them, so we will have the invert of the result here. So for A, B, C, D to the G, we use the SOP or POS, depends how much the 1 or how much the 0 here. So for the code of this approaches is here. We use the module here will be 5 outputs for the display and 3 output for the module and 5 input for the module. So we will have input, output, and output, and we register for the F that will be 2 to the 0, 3 indexes. And in the always add block, we will use the formula for F is equal to the combination of x1 to x5, and we assign for the each F2, F1 of F0 to the index of the F, and the assignment is the expressions we choose for 1 or 0 in the table we just showed. So I also compile for this code, and totally is 11 warnings and 0 errors. So we can see that the first will have 12 warnings, and the second will have 12 warnings, and the third one only have 11 warnings. So the most cheapest way for the project to get the same output will be the third one, that the most less costs. Thank you for listening.